In this video, we're going to cover the configuration menu for the Tally and GPIO section specifically. We've added a few new features as well in version 9, so this one's a little bit better now. Under configuration, you're going to head over to Tally and GPIO. Here you're going to find a couple of different sections. Well, actually a few. So one of the things to cover is we are going to move from Tally to GPIO and then come back to explain it, but it just allows us to move in a sequential order. So when we talk about external Tally, we're talking about the physical Tally connector on the back of the unit, but associations to external physical inputs. So similar to what you saw in the input menu, our first list is of your physical BNCs, and then we break it up by having a separate section for all of those internal inputs, because we have all the media stores, all the MEs, all of the clip store, we've got the aux buses. Technically, all of these things can be taken as a source. They're a follow, which we cover in a separate video, but those could be taken as a source, and maybe you want a physical Tally to trigger when you take that source. So it is possible, just keep that in mind. Now, when you look at these columns, you will see there is a GPO column. Now, the GPO column does allow you to select a GPO, and you can even set a pre-delay. So pre-delay is a pre-roll. That way you can use it with roll clip. This is if you had a source that you needed to trigger something, but it doesn't take ROStalk or AMP or a device control that we can send over the network. It needs a good old 5-volt trigger. Well, you can go ahead and you could assign one of these, and you could tell it that it needs 5 frames to send the trigger before it takes it to air, to give it that time to register the trigger and play said video. This also can be used as a Tally. So if the device is actually set up in Tally mode, then what you're going to see is those will show up under GPO Tally mode. So these are two totally different use cases for GPOs as a association to the Tally state of an input. So these are going to go on and off based on the Tally. The other thing is when you're assigning Tally connectors, these physical connectors, which when you look on the back of the frame, there's one DB25. It's covered in the configuration guide, but there's one DB25 which has the 24 Tallies and the common on it. Tallies are contact closures. So these are open collector transistors. They aren't going to pass high amounts of amperage, but they're perfect for things like CCUs where you wire them in. It's providing the amperage that passes through and closes its switch, or it's going to provide it to put on the physical Tally lamp. GPOs, on the other hand, are going to provide a voltage. So you may have a LED wired up, but it doesn't have a supply voltage. It must be given a voltage. And so instead of having to go out and build a project box and put a relay and put a 12-volt or a 5-volt system on that, you now have a 5-volt system you can generate from inside the switcher. So again, a really cool feature that you're not going to find in most other production switchers. So these two elements are going to show up in this menu based on how you configure your GPIO. So we'll cover that in a moment. So it is possible to enable multiple pins to be controlled by this source. In this example, whenever input 1 is on air, physical Tally pin 1, 2, and 3 would be closed. And so therefore they're going to connect the common all the way through to the device. If I want a second pin connected, for example, to my camera CCU, that way I could drive a preview Tally, then we do have a preview column. So this column allows me, again, the same type of configuration. It's just now it's only going to turn this pin on when input 1 is in preview. So that does not mean on preset only. That means a calculated preview. So it could be a keyer that is in the next transition, and in the preview window, I see that that source will be going to air. Or it could be that that source is on ME1 in a DVE box, and currently ME1 is selected as the background on preset, and therefore it's next to air. That source also would tally correctly. There's really no difference to internal tally. They work the exact same way. But then we come to the GPIO configuration. So the GPIO, so that's general purpose interface, it's an in and an out on the same pin. Each pin is bidirectional. It's also on a DB25 with the pinout listed in the configuration guide as well as in the quick start guide. So if you looked at it inside of the quick start guide, you got it next to the tally connector. You're able to wire those up as separate DB25s. You wire them in and you treat them how you need to. So with the GPIO, the difference is that each pin can either be set as an input or as an output. Here what you'll see is these first units, 1 through 16, are all currently set as inputs. The other thing is that because the inputs do have pull-up resistors on them, they will pull high. So unless your device is forcing it low, it will automatically pull high. This is also needed when you want to use a simple short to ground. So you want to be able to take pin 25 and short it to pin 1. That's how you do it without the need to supply voltage. However, if the device is providing a TTL level, we can manage that. And so this column is showing you what the current state is. So it can also be very helpful in you're able to see what is the device currently pulling it up or down. The first configuration under Edit allows you to set the pin to either output mode or input mode. If I set it to output mode, you'll notice now the level status changes to a trigger button. So you have the ability to press this button to test trigger your GPIOs. No longer are you forced to go in and build a custom control just so you can then test it. You actually can trigger it from the menu. So looking at GPIs, the second column, or second row, sorry, the first column, GPI, the second row is now going to show us what event is going to trigger when the state changes of the GPI input. So if this is shorted to ground and it's driven to a level low, what's going to happen is it's currently going to run the key auto of ME program preset and specifically key 1. If it was ME auto, then you would be picking your ME. Some of these events, like picking an aux cross point, so I want to do CCU joystick overrides. So great, on joystick 1, I'm going to use GPI 1. Well, that aux output that's going to the monitor for the shading station, I want that to switch to input 1, which would be camera 1. And then on our next one, we're going to want to do an aux cross point, and that one is going to be camera 2. So as you can see here, we would be wiring up our CCU joysticks, and as soon as they short those to ground, it's going to switch the aux bus to that source so they can then shade that camera. Also with inputs, if there isn't a direct event like fade to black, ME cut, doing an ultrascene recall, doing a memory recall, I tell everybody, no problem. Assign it to a custom control, go into that custom control, you can build anything you want the switcher to do, and you now have a way from an outside trigger to make the switcher do anything. Note, these GPI triggers are also linked to ROStalk. So if you send the ROStalk GPI 3 command, it will trigger custom control bank 1 custom 1. Of course, if your device is able to send ROStalk commands, you could have just sent the CC directly, but this allows you that indirection. You might have some event that you want that external button to change what it does depending on a different show, and therefore it could be a different custom control you want it to trigger, but you don't want to have to go back to that device and reconfigure it. So now let's go and look at what happens when we configure a device as a GPIO. So first up, when you put it in GPIO, you can choose between low or high. So what is the default state of the trigger? Do I want it to trigger low, so in which case it starts high and it moves low when it's triggered? Or do I want it to start low and trigger high? So in this case, for a Tally, I'm trying to drive 5 volts to a device because it couldn't work with a contact closure and supply the voltage. So I'm wanting to give it 5 volts, not 0.3 volts. So I'm going to set this as a GPIO. I'm going to set it as high. Also, I want this to be a level, meaning it's not going to trigger. If it was an edge, it's only going to stay high for the number of frames you set this to. You'll also notice we disable the ability to make it a Tally mode because Tally is on or off depicted by the switcher. It's not a pulse. So we're going to go ahead, change it back to level, and now you have the choice of normal or Tally. So in normal mode, I would be building a custom control that is going to tell it when to set the GPIO on and when to set the GPIO off. Whereas in Tally mode, we're setting it up so that we can use it inside of the Tally system. And that way, when we go back to external Tally, that's how we were able to select it here as one of the options. So now, Tally 1 might be the camera CCU, which can provide us voltage, but I need to trigger a light that's inside of a room that's got it that is separate from the CCU. So that might be a great way of an exterior on-air light for a small pop-up room so people know not to walk in and interrupt your training sessions. But that device needs voltage supplied to it. It can't pass voltage through us. And so here, I've now set 2 things up that anytime I take camera 1, both those items will tally. Next up, as we expressed, there is the use of edge. And you can, with anything that is set to an edge device or that's set up to a GPIO, normal, so even if it was a level, but normal, now when you come back to your Tally section, you can associate those with the GPIO. So there might be some devices where they can intelligently have a on and an off, and they have 2 states. So I want to use those in a level mode, but I want them to be normal. So normal but level, so it can have an on and an off state. But maybe, like we saw with 24, it's a device that can't support a level and it needs a trigger. So it needs a pulse. And a lot of times that's because it sees the rising edge and it waits for the falling edge to confirm that it's supposed to trigger. And sometimes you need to set those durations between 7 and 10 frames depending on the device so that they don't perceive it as noise on the line. It's held long enough that it triggers their interrupt. But any of those can be used here where I can associate it with an input and a pre-delay, and that will all track with the roll clip functionality of the switcher. That way, anytime the source goes to air, it actually waits on the cut or auto trans function, sets the GPIO, waits that pre-delay, then performs the transition for you. So those are your GPIOs, and of course, at any time, you can also manually trigger them from the menu. However, the newest and coolest feature that we've added to this system is the new TSL5 Tally input. We can now hand off control of our physical I/O to an external TSL5 Tally controller. This is big for a TSI 4000 or Ultra Tally system where we might have multiple switchers and we want a way to make the physical connectivity to the different cameras in the different studio available to everyone, just like we would with the Tally system, but now we don't need separate physical Tally connectors. They're already in the switchers. So you head over here, you create a new link, you're going to tell it what address. So this is similar to how we saw things in the input menu. We're picking what address of TSL it's tracking, what bit. So in the TSL UMD5 protocol, there are 6 bits of tally. So usually 0 and 1 is the left set of lamps. 0 for green, 1 for red. Both 0 and 1 would turn on to make amber. So what we have here is the ability to track all 6 of these bits and link those 6 bits to a physical tally. So they can use this however they want. They could create for us, red, green, blue, amber, yellow tally bits that they send in and trigger, because on the camera they might have 3 or 4 different color tally inputs, but they need those physical connections to them. So here we're going to set bit 0. We're going to tie that to input 1, to tally output 1. So now tally output 1 is going to be driven by bit 0. If bit 0 is low or off, tally 1 will be off. If bit 0 is set with a 1, it will tally that connector. So there you go. You hit the save button and you have now added a new element that will trigger that device. So you can go ahead and you can build out all the physical tallies that you want to associate with different tally bits from different tally TSL5 input elements. We think this is going to be a huge, huge advantage in this product series, because now you will not have to buy external hardware. And now when cameras are directly connected to a production switcher, a completely separate production switcher could be sending TSL5 protocol to that switcher to also trigger the tally state. Questions? Requests? Suggestions? If you have any of those, please send them to switchers@rossvideo.com, and we'll try to get to them in either an email or a video. As always, thanks for watching. Have a great day.